So, welcome everybody to this third inaugural webinar in the Iliad Hackathon webinar series. We are launching the hackathon with some information about the themes of the hackathon. And today we are covering interoperability between digital twins. And we have Tom Red from HubOcean that will go in more detail what the themes are and what the hackathon is about. Then we have Pierluigi Buttigieg from, hi Pierluigi, from, actually he's representing Ditto and Turtle, which he will speak more about on interoperability, global interoperability between digital twins of the ocean. And then we have Raul Palma, who will introduce one of the technologies standards that we are developing in Iliad, the Ocean Information Model. And then, of course, at the end, we will have Q&A. Well, you can also ask questions in between, of course, and do use the chat as you come with, you have comments or you have questions when you are listening to the presentations. Please write it in the chat, and then so we will have time to answer questions and comment on your comment. So with that, Tom, let's hear about the Iliad Hackathon that we are embarking on.
Yep. Hello, everybody. So this is, as Bente said, this is the third webinar this week in our series kicking off the Iliad Hackathon. The hackathon is planned as both a virtual and an in-person workshop of hackathon that will take place in September in Oslo. But the idea behind the virtual session is to open this up to as many people that want to join to sort of learn about some of the things that we're doing within the Iliad project and also outside of the Iliad project. So the themes that we're covering in the hackathon are digital twins of the ocean in action. So how you go about building a digital twin of the ocean. And so we have experiences from within the Iliad project and outside of the Iliad project. We had a webinar about that on Monday. Yesterday, we had a really interesting webinar about large language models and how they might interact and connect with digital twins of the ocean, and sort of a new way of thinking about utilizing and using digital twins of the ocean. And today we have a really interesting session and a really important session on interoperability. So I think a lot of people in the call will be in some way involved in a digital twin project, whether that's Iliad or outside, or could be also international. And so everybody knows that interoperability is a big topic and a big issue, and very fundamental in building digital twins. So we wanted to put this at the sort of one of the core themes of the hackathon of how you can build your digital twins to ensure their interoperability between each other, and especially at the kind of more fundamental data level. So we have two really interesting talks today. One, as Bente said, from Pierluigi, who will talk about the international perspective in interoperability and the UN sort of initiatives that are ongoing to try and ensure interoperability. And Raul from the Iliad project, who's going to present one of the tools that's been developed within Iliad to sort of help people create their twins to be more interoperable. And so I'm really looking forward to both of those talks. So I'll hand over at the end. After we've had the two talks, we'll have some time for questions and answers. And then I'll give a little bit more details about the hackathon and the next steps going after these kind of kickoff webinars. So I think I'll just hand over to Pierluigi for his introductory remarks.
Yes, Pierluigi, and before you, while you are sharing your screen, I apologize for not presenting myself. Bente Liabi is my name, and the Iliad Innovation Manager, and run a company, BLB, here in Norway. I forgot to introduce myself. But Pierluigi, you work also at the Alfred Wegener Institute. In addition to this global projects you are involved in.
That's correct. Actually, my participation in things like Turtle and also the IODE activities is funded by Horizon projects, World Fair, Marco Polo, and not here, but BioOceans 5D. And again, my role is trying to make sure that whatever we're doing in Europe can connect to something bigger and federate in a global context. And so quite a lot of my time is given to help IODE, so the International Oceanographic Data Information Exchange of IOC UNESCO, build interoperable data systems writ large, and then they overlap with digital twins, etc. So that's what we're going to talk about today. I'll be a bit terse. I understand this audience is a bit more technically fluent than usual, so I won't go through the whole story, but just the gist of it, right? So then we can get into a hackathon later on in this series and then do some exciting work. So one of the most important things that we've realized is that, we already are in a digital ecosystem. That digital ecosystem has technology, federated networks, it has the over the web, etc. It already exists. The hard part is the social part, the socio part of the socio-technical system of a digital ecosystem. But getting people to agree on how to align their implementations so that they can accomplish their missions at home while still interoperating with other systems with very different priorities and very different capacities is tricky. But now that we have the UN Ocean Decade and we have an international, let's say, a more internationally mandated forum to come to such agreements, it's an exciting time. In the original conception of the UN Ocean Decade, the implementation plan that came out before the decade started in around 2019, 2020, there was a section on data that myself and many others helped put together, and we emphasized the need for linked open data on the web. This also applies to software. It also applies to any kind of digital resource, including the twin architectures. And that's the sort of spirit that we're continuing on so that the world can actually meet each other and interoperate. Since that implementation plan and data and information strategy came out in 2022, I believe, I recommend that you take a look at that. And what we're doing now after that, Kevin O'Brien from Washington University and from the Global Ocean Observing System and myself are co-chairing a group going to soon release the implementation plan. So more concrete advice on how you can make your systems align to the data and information strategy. It's within that sort of overarching framework that we'll talk about digital twin interoperability. And actually, this is not new stuff. It's mostly trying to get the scientific community, the research community, the innovation community, more aware of good practice when it comes to engineering data systems, trying to sort of show that we already have the internet and how to use it very well. That's the idea. One of the first digital twin of the Ocean Summit, the Ditto Summit in the UK, Terry McConnell had this graphic that I keep repeating, that everybody wants these sparkly fountains. Everybody wants the fancy digital twin that looks amazing and policymakers, shed a single tear because it's so beautiful. But in order for us to build that, it's important that we build very robust plumbing systems underneath it. That's where the important bits happen. Plumbing systems are the foundation of civilization, not fountains. So when we're building our interoperation of twins, we have to get into the details and talk about what kind of components are in those twins and how do they work together. When we do that, then if somebody is asking a question to a certain data system or so, and if they don't have the answer, they can also ask other very different data systems around the world or digital twins around the world that same question and see if they can deliver something back. So all of this idea of one-stop shops for feeding twins data, sensor information, that's kind of old news. That's like 1990s, early 2000s. We have to make sure that our systems can talk to very different other systems around the world. So as we're all building our digital twins, they can share information. At that UK summit, we talked about the various parts of digital twins. And it's all there. We are all doing something similar. The second conference for Ditto was in Xiamen in China, so we got to see some of the ecosystem there. It's all very similar. There's no point in trying to make a different nation implement one of these blocks the same way you do. The task is to make sure that they work together, and then you can move them between different twins around the world. So in the future, what does it look like? It looks like, when somebody goes out and sees an interesting crab somewhere on a reef, they start to call ships with submarines, with other kinds of observing technologies, and they start feeding all this data into a digital ecosystem. Of course, a twin is going to pick that up. And you will build a twin, somebody will build a twin that will do its job very well, and then circulate products back into that digital ecosystem. That exchange is often under-stressed, but very important. Twins are just another component of a very big digital ecosystem that goes beyond them. But at any rate, they're going to have the same components, the extract, transform, load modules, your model and machine learning stacks, virtualizations, user experiences to generate that twin. But when you have that twin and something new happens, that twin might not know what that thing is. If a new species comes into that ecosystem, what does it do? That same logic occurs, it should be able to ask other twins around the world, hey, have you seen that thing? And then gather data sets, software containers, and others into its own ecosystem, test if it works, integrate it, estimate how much it will cost to recompute information and recompute itself in terms of money, yes, but also carbon. These things are computationally expensive at times. And then deliver new updated twinning technologies back to people so that they can publish reports or whatever else they need to and circulate it back. That's the goal. That's the kind of success metric. If we are able to do that, then we've built a digital twin community in the Ditto vision. So what do we need to do? Well, the action we need for that, we think about what happened in 1955. It was a really fun year, and if you were around. But then this chap, Malcolm McLean, he came up with a very interesting idea. He came up with this thing that took us from longshoremen and people adding cargo to ships in a sort of haphazard manner to the modern container ship. That has been emulated across our digital technology with things like Docker and others. What his fundamental insight was that, look, the main thing about shipping is not sailing ships, well, shipping industry. It's about moving cargo. If you redesign your ship, it's still a ship, it's still your ship. But if you redesign it to be compatible in terms of the cargo it's shipping with other ships, the world will change. And that's the question for us. How do we redesign our ships, our digital twins, to move insight knowledge technologies around? And so at that conference, we saw many different kinds of architectures. The Edito suite in Europe, Amazon, the private sector is moving in, and NOC in the UK, they had a very interesting perspective in their reports on how to design their twinning frameworks, and it's how to federate their twins with other twins. And that's a term, we use a lot in the IODE when we built data federations for the UN Ocean Decade, building these supply chains for not just twin artifacts, but data in general. I won't go through the details. There are many presentations about ODIS and OIH, or this Ocean Data Information System that we've built. But the whole idea was, again, to help people use the web as it's supposed to be used, so that all of these local and regional implementations, some of which are millions and millions of euros, some of which are just one group somewhere, they all can start talking to each other more effectively. We started in regions which are typically underrepresented to make sure that it works everywhere. And those regions had led in a much larger consortium now, representing hundreds of institutes, to actually exchange data products, metadata about software. And we're monitoring that in real time through our dashboard so that we know this thing is actually happening. We know that the code is valid. We verify the data exchanges between these different ecosystems. And as that graph grows, as this federation of data grows, we can monitor it through time and make sure that each one of those nodes inside is exchanging data well. I would like to see this for twins. And indeed, twins can just be another one of these nodes. Your twin is letting other twins and other data systems know what it needs and what it produces and what it can do. I'll skip this a little bit. This is more for the hackathon later, but just to reassure people, we're not reinventing anything. We're using standard web architectural approaches. We're just making sure they work for the ocean. So the big five, Google, Microsoft, Yahoo, Yandex, etc., they can all pick this up if they want to. There's nothing different about it. The same person that designed your website for your barbershop should be able to do this. So that is our container. So we figured out the concept, and now we've actually built it. Things are exchanging information, and we're working with Ditto to get people's data on the map. I'll skip a little bit, but basically, for the first time, different data systems around the world, we can see who has what data in a certain region. When the UK joined, they had a few test cases, and then they really went for it and shared out their data holdings from Medin, representing about 400 to 600 institutes, I'm not sure. So it's happening. We now have this federated index to a data lake, a global data lake with all sorts of different data and software containers and services. If we get our twins on that map, we have a concrete way. So again, in the spirit of a hackathon, a concrete working way to let people build things, to let data scientists investigate, and for us, our engineers, to test and verify that twins are working. So it's not just fancy presentations, it's really testable ways to get to a data space, get from our data lake towards more advanced and integrated and globally fair, not just locally fair, but globally fair digital twins. What next? It's time for us to build this intermodal container. We have the same logic. We have some wonderful things happening around the world. I'm sure many of you represent it. Iliad indeed has its own advancements here. And so what we have to realize is that our core business is not necessarily building the sparkly fountain. It's not necessarily building the fancy virtualization, but that plumbing system. That's the thing, the data integration around the world. So I think I'll end there, but just to let you know, Turtle is in effect. We have I'll put it in the chat later, but we have an open GitHub issue where we're actually developing the interoperability specifications for twins, basically defining what that shipping container of software, of data, what it looks like, sharing the metadata, and getting the twins talking to each other. From there, many things are possible, and the world is open. So back to you, Bert.
Thank you very much, Pierluigi. It looks like it's all set up to connect. And a quick question. So is this going? Well, you are publishing this soon, you said, and this will be available freely open to everybody then to.
Oh, yeah, so the implementation plan for the UN Ocean Decade is coming soon by the end of the month. That has a lot of broader details about how to implement it. This issue right now is open right now. I'll put it in the chat. All the development is done in the open. Anyone can join and try their twin in the framework. So I'll put that in the chat later.
Great, thank you. And we can come back with more questions to you at the end also, Pierluigi. So thank you very much. And we are moving on to Raul Palma, working at the Poznan Supercomputing Network Center. Raul is our expert on ocean information model. He works within Iliad, of course, but also very closely with OGC and the standardization community. So Raul, are you here with us?
Yes, hi.
Sign up live. Yes.
Sorry, I'm not getting to the better in a second. Okay. So I'm here.
Here you are.
Okay. Great. So should I start?
Yes, please.
Yeah.
Yes.
Okay, okay. Fine. So hello, everyone. I will just start sharing my screen now. Presentation mode. Okay. So thank you for the intro, Bente. I will go a little bit into what we are doing in Iliad regarding the provision of the semantic interoperability components or building blocks. And one of them is called the Ocean Information Model. So that's like the core of our approach. So I will go a little bit first just to give you an idea of why and how did we come with it. Of course, as you know, there is a explosion of data that is generated by many different types of systems and platforms. Normally, they don't interoperate. You can see like the software landscape related to our domain where hundreds of providers can, are giving some kind of solutions. So rarely they have some interoperability between these different platforms. So obviously there is data that is available in different formats represented according to different models. And the interoperability mechanisms, to connect existing ocean-related models are still not sufficient. So of course, the approach for semantic interoperability is to make sure that there is a common understanding on the meaning, on the content that is being exchanged between these different platforms and different systems. So that involves, for example, having some kind of common information models and the interoperability mechanisms to produce and consume the exchange data. There are several standards available, of course, but instead of rebuilding the build all the time, now more recent approaches aiming at enabling the interoperability of different standards and models, so like aligning existing standards. So going into the Iliad part in particular, the digital twin, as was mentioned also before, digital representation of the real world entities or process, enabling the data storage and management, and offering some kind of functions to exploit this data. But the important thing here is, of course, that they feed on a wealth of data that is coming from many different systems. So they can come obviously from different administrative boundaries, require agreement and so on. But the important thing is, again, we are dealing with data coming from many different systems. So there is a need here to represent this data that is being harvested in an interoperable way across all of these systems. And this is what the ocean information model aims to. So basically to establish the basis of a common ocean data space, enabling the interoperability of different systems and the analysis of the data produced by those systems in an integrated manner. So OIN was designed following a modular approach in a layer architecture, taking into account the requirements in Iliad. It was realized as a suite of ontologies and corresponding JSON-LD context, because we are, of course, aware that for developers, the most direct way of implementing this kind of models is via the JSON, because it's the most commonly used format for exchanging data. So we have, of course, created the JSON-LD context that referred to the ocean information model. And it's published and made accessible via permanent identifiers, in particular the W3 IDs. Also is implemented in line with best practices, so reusing existing standards and establishing alignments between those standards and models to enable the interoperability and integration of existing data. I have to say that the ocean information model was not created also from from the beginning. Actually, what we did was reuse existing results from the past, in particularly some of the layers that the ocean information model has have been reused in the past from other domains and adapted to the ocean domain. So this gives you a high-level view of the ocean information model. So as you can see, we have at the top level some kind of core meta model layer, which is based on the NGSILD approach. Then we have some kind of cross-domain layer, which provides some kind of terms and definitions that are relevant across many different domains. Then the domain-specific layer, which is in our case the Iliad, the ocean part. And then we have some pilots and specializations that are really necessary sometimes, not necessarily every time, but sometimes they're necessary in order to represent the data from those pilots. Also, we have a metadata layer and connections to, vocabularies. Here you can see the repository, which is available, and the namespace, W3ID namespace to access the model. So I will not go into all of the different, models and standards that are being reused. I'm just particularly in the cross-domain layer. The idea here is to avoid conflicting or redundant definitions of the same concepts, in different domains. So basically, this is like one of the core parts of the interoperability of systems and tools that are applicable to multiple domains and applications. So this cross-domain is really trying to represent all of these terms that are generic enough, that are replicable in many different domains. It's based on several OGC, W3C, ISO standards, and this is more or less how it looks like, of course. So you see some bubbles there from some of the most prominent models here, using the cross-domain layer, and those are connected into the NGSILD as well. Then, of course, the domain layer defines more generally applicable ocean concepts and properties. Of course, particularly we are focusing Iliad pilots, but obviously we are aiming to have some kind of generic enough domain layer for the ocean domain. And this is based again on standards like, the Darwin Core glossary of terms and its extensions like this Humble extension, the marine biography extension. But also we are reusing standards like SAREF, smart data models, and the climate and forecast futures in order to align all of these different models at the domain level of the ocean information model. So once we have all of these layers, as you saw also in the diagram, we make some alignments with some vocabularies. We have, on the one hand, essential variables. I don't know if you are aware, so there is some kind of trend in order to define what are the essential variables for different domains. For example, the essential climate variables, essential biodiversity variables, essential agriculture variables, and so on. So there are like 20 different essential variables that we are connecting into the ocean information model. Also, of course, worms. It's a very well-known list of names of marine organisms, including information on synonym. So this is very important, particularly for our pilots. It was very useful to have all of this information connected to worms. And then, of course, we have the variables coming from climate and forecast, particularly those related to the atmosphere, the surface and ocean domain. And also AgroBook is connected in somehow because it has still some relevant concepts that are relevant for Iliad. Obviously, we have, like I said, some metadata layer, again, based on standards like DCAT, which is very well known, IDS information model, the DCAT extension for quality information, this is DQV. And then we have also integrated the OGC coverage implementation schema and some properties from the Adam platform, which is one of the providers from Iliad. And these have been also, as you can see here, aligned in the ocean information model. So what is the benefits of this modular approach? First, of course, is the interoperability with existing models, the alignment of models by module instead of the whole ontology or the whole model itself. It's easy to extend to different domains and areas not covered in OIM. And the maintenance, of course, is much more easier, as well as the mapping to other cross-domain ontologies. So in practice, how we are using this, we are doing something like we call the linked data pipelines, which basically get some data from the original data sources, do the process of data harmonization, basically based on the ocean information model in order to generate some standard data that can be consumed by the analytic services. This is, some interface, how these pipelines look like. And then after that, we have the model, we have the pipelines to do the harmonization, but at the end, how to expose this data to be consumed. We also are, trying to align as much as possible, whenever it's possible, to existing standard APIs, for example, the OGC APIs. So there is a way to automatically represent, for example, measurements and observations data that is conformant with OIM in the Sensor Things API. So you just do the harmonization into OIM, and then you can automatically expose the data in Sensor Things API. So this is something that we have also been implemented and tested, of course, in different pilots. In Iliad, for example, the jellyfish pilots started from CSV data coming from the observations of the jellyfish, do the transformation and harmonization, and this goes into some semantic triple storm, and then from there, we can expose it into this Sensor Things API interface. Obviously, you can visualize this data in other interfaces as well and get some insights like, some kind of statistics and so on. But the most important is that data coming from different sources can be visualized in this way because all of them will be harmonized according to the same model. And yeah, that's from my side. I hope that I didn't get too much over time.
No. Thank you. Thank you very much, Raul. Indeed. And we are switching between, overviews and this time details. So the devil's in the details, as we say. So when you want to make this twins interoperable, there's a lot of bells and whistles that we need to pay attention to. So thank you very much, Raul. And I see here that Pierluigi is very actively contributing. Yes, so yeah. So I think Pierluigi, it's more. It would be good for you to take the floor and ask the questions and comment directly. I think this would be useful for all of us.
I'm just taking notes on the way so I don't forget, and also it gives the audience some time to think about it and also contribute, right? But I'll kick it off with some, again, in the spirit of a hackathon. I like hackathons because it's not like a high-level meeting where everyone has to just always be nice and everything's a success, right? We can actually talk about the details and say, wait a second, this could be a problem, right? So, Raul, I think it's a great, it's cool. But I think how Bente, you phrased it initially, this sort of ocean information model is a way for like the Iliad ecosystem to stabilize itself, kind of get the house in order. And then when it comes to like a global thing, like with Ditto or Turtle, they can project it out in the international formats too, right? I think a lot of the time the mistake comes when other twins who may have a very different implementation architecture hear the message the wrong way and try to implement components that don't necessarily fit how they work, right? So I think as long as that's clear, we're cool. But then Raul, I just had some comments on some of the choices, and working with Arna in Turtle, I'm familiar with some of it. I'll start with the vocabularies and ontologies, right? So this is close to my heart because I'm a semantics person. I build ontologies. And what happens in Europe, but not just in Europe, in the US also, but also Australia, there's this conflation of things like vocabularies, thesauri, and ontologies. These are all very different things, right? And especially now that we're in an AI world, we have to kind of be precise, right? So for example, NERC produces SCOS level thesauri. They don't produce ontologies, right? Agravoc is also a SCOS level thesaurus. Climate and forecasting is more vocabulary, kind of a glossary-ish, right? Things like you said fish ontology, that could be a full ontology in OWL, right? So it's just an encouragement really to it's time now to get really precise about that. We've always been told, let's use general terms so people understand it. But now when we're having hackathon level conversations, we got to get serious, right? Because it's like saying, here's a screwdriver and you give me a hammer, right? I don't know what to do. Yeah. So that's one thing. And I think for us communicating, it's really, really important. There is a program, a UN Ocean Decade program called Ocean Data 2030, which we're kicking off from IODE. And we have a big glossary at the end of the implementation plan for things like basic stuff, data, information, knowledge, right? So I noticed that you had a ocean data ontology or something inside your slide deck. I strongly encourage you to sync with us there so that whatever we're doing in Europe or whatever you're doing in Iliad also can have a semantic correlate outside. I say that because, again, Europe is starting to use, as data becomes more popular, people who are not data folks are starting to use terminology in a kind of Wild West way. And it's our responsibility to rein that in. Right now in the European Commission, a data lake does not mean a data lake anymore. Partly we don't speak up. The people with the technical knowledge don't speak up and say, slow down. So there's some comments there. I don't know, anything you want to respond to, or if the audience...
Yeah, so for sure. I mean, like, as you saw, we are really connecting different resources, semantic resources, of course, from different formula, different levels of formalization, of course, as you said. The thing is, at the end, what we really were trying to focus is on simplifying a little bit the use on how this will be in practice implemented, and by the developers, by the solution providers, in the pilots, and in Iliad, of course, but also beyond. So, of course, we are representing our semantics, the model in an ontology, modular ontology, of course. But then what developers would get are, the context, and then some kind of validations that we are trying to implement also with the shackles, so that they may be able to validate that the data complies with the semantics of the ocean information model. So yeah, I mean, obviously, we are trying to abstract, of course, all of the, where are these terms coming from to the developers and implementers of solutions. We are just trying to give them, like, the JSON LD so that they can start working on with that, because we have seen that, in practice, this is the most common approach for solution providers. They don't really care much on the actual implementation of the ontology itself. It's more how to use it and how to validate that the data is complying with the semantics that is represented in this model. So
yeah, I appreciate that. But, in what you're saying is also the trap, because yes, you can validate things. Anyone can build a standard, right? Even if it's not an official one. And now the key, remember that digital supply chain, right? So from local to regional to global. Success, I think, for us looks like, all right, if they're passing the Iliad validators internally, right? Does that also mean they pass the Turtle validators globally, right? If that is true, then we've succeeded in terms of interoperability, right? We have these great examples, like from the UK, Medin, so their data system in the UK for marine environmental data and information. So they have a national standard, which a lot of the UK institutions that push data to them conform to. Then they do the job of converting that into the global stuff and pushing it out to UNESCO and other systems. If twins like Iliad, not just Iliad, but twins in general, many of them are asking people to give them data in a specific format. That's great, but if it's a dead end in that twin, it's not really helping the world as such. It's good for the twin, it's not good for everybody else. if we can say, and what you showed is very mature, you have all the right pieces. If we can say, look, if you pass the Iliad validators, that means we understand what's in that data, and we can help you convert it to forms that we can share with other twins around the world and the system. That metric is, I think, then the key for success. Interoperability locally transforms to interoperability globally. If both of those aren't true, then we're in a capture scenario, right? Where a local implementation or a regional implementation has captured data and you have to use its standards to access it. We have to really avoid that.
Yeah, no, I agree. I mean, like definitely as you see also all of these kind of interoperability approach in Iliad is taking like three main blocks, right? So of course the model, the ocean information model, the part of the data harmonization, and then exposing these via some standard APIs. So that's like at the end trying to make accessible the data, is interoperable and using some standard that can be consumed by not only Iliad, but by twins and other applications outside.
For sure. And I think that's like what modern systems look like, data systems. Now, the trick is those APIs that are exposing it, somebody has to be listening to confirm it's interoperable. Right now, like in the past 10 years, fair usually means like it's a claim, right? Oh, we're fair, here's our API. Somebody has to validate, some third party independent who's not in Europe, for example, has to validate, we understand, we can interoperate with you. And that's exactly where the whole UN Ocean Decade can help, and Turtle and Otis and others. Let's do that because you're building it anyway. Let's find a partner, another twin somewhere else in the world, and say, can you understand each other? Then we know it's really interoperable as opposed to a claim. And then we're fine. Because that's how we can like co-develop the specifications.
That would be really great, of course, to have some kind of interaction with people outside.
And I just wonder, like in the audience, I mean, I know in Turtle, and also in Turtle, we're quite Europe heavy. You know, we have a few other twins in there, but I mean, anybody in the audience with a twin architecture or knows of one that can help us find another testing partner around the world? Don't be shy. I know we're just like chatting about, arguing. I hope it's entertaining, but
it's not only entertaining, it's also very useful. So, yes, the audience, I saw some names that looks like non-European. Tom, do you have did you notice I haven't really where did I put all the participants? Yeah, don't be shy. I know there's Pierluigi. I know they are moving along in the US. They are a little bit, not so complex twins. That's my impression from the presentations I saw in the European Geosciences Union.
Sort of yes and no, right? So I was at a National Academies and Royal Society meeting. And, it was about digital twins. But the thing in Europe, digital twins have become a big kind of policy thing too, right? So we talk about it with great confidence. However, if you show somebody in the US, Australia, China, Korea, Japan, if you show them the architecture that Raul just presented, they'll recognize it. They have all of these things. They just don't market it in the same way, right? So part of what I think we need to do a little bit better is communicate not the high level, we're going to twin the ocean sort of thing, but saying, look, we're building an integration layer. We're building a virtualization suite. We have a model, we're getting our models organized, right? So I think communicating at a lower level with the technical people will actually bring many more people involved, because the US definitely has systems that can do most of the stuff that was just shown here. They just don't talk about it in the same way.
Yeah, well, yes. But now I want to, I have a question concerning this interoperability layer. And you mentioned, I mean, one of the things that I see as an advantage of the ocean information model is to actually have control over the different definitions of the parameters that we are using. This has been discussed in Geo, where Geo is global, Pierluigi, right? So that's where you have all the regions represented, and we are discussing, the Ascension ocean variables. We are, these are discussions, and all the same. And we have also discussed having no vocabularies, having everything, as long as you have one standard, everything is okay. I've seen it waves, you know, the waves have been going back. No, we need some sort of control vocabularies in order to be able to speak to each other. And then we are now, I see the ocean information model in a way of organizing the different definitions of the terms.
Sure. Yes.
Yeah.
But again, at a local, or let's say now at a project level scale, organizing that, right?
Well,
So again, I'm on the Goose. I'm on one of the EOV panels for Goose, right? The biological and ecosystems one.
Yeah.
There are terms that are present in some vocabularies for EOVs, but Goose does not recognize these as official. Right now, we're working on the actual specification with Goose to get them to recognize something as an official specification. Because it doesn't help if a European project says, look, here's a model. This is now the standard way to talk about EOVs, and Goose is never part of that conversation, right? That's missing a little bit.
Yeah.
In some of the projects like Marco Polo and others, you know, we're building links. We have the consultation process. And in Otis, we're helping Goose panels build portals that will harvest information that complies with their specifications. I think that's what's missing. I think it's great that things like this model are getting locally the house in order. But now for worldwide projection, we have to be very careful with our claims. We can't say that we have EOV data products unless Goose can hear us, right? Unless Goose says, yes, we see them. Otherwise, Goose is the custodian of the EOVs. If they can't see it, what is it, right?
But Raul, have I misunderstood? Because there are different. I mean, you can use different vocabularies. That is, you know, different ways of talking about the describing the EOVs. But then in the ocean information model is a vehicle to actually map those. You know, okay, this term means exactly this term.
Yeah, exactly. So that's what I was saying. I mean, like the ocean information model is not just like you know, redefining some things, right? So we are of course trying to get standards and then aligning with other you know, existing models and whatnot. So basically, what we need to understand at this moment, I guess, is just to know to which other of those you know, ontologies or models we really need to be more compliant, just to make sure that this is aligned. But it's not like it's not possible, and that's of course like also the benefit of this kind of modular approach for the ocean information model, where you could really map into many different other models as well. So that's one of the main benefits.
Yes and no. So I agree with that. Mapping is important. I think that's going to be a reality. So, for example, in Europe, we have to use like Inspire for reporting to our agencies. We have to. In the US, they have similar mandates. They have to use a certain standard. There's no way around that. But we should not make the mistake of trying to impose that on other countries that don't care about that framework. So that's exactly where that mapping comes in handy. I put a question in the chat. There's this SSOM or CSOM format that we're recommending from the code data level in CDIF and others, to actually have a programmatic way to read those mappings with SCOS predication. I'd encourage you to look at that, because if you're doing those mappings, and mappings are hard. We just finished something for WMO with cryosphere mapping. It took 2 years to go through the terminology, right? If you want to do serious semantic mapping, like looking at the definitions and seeing how they match, it takes a lot of work. A quick and dirty mapping is fine, but that's not what we need actually for some of our applications. It's very useful. But I'm for sure that Iliad does not have the resources to do a full semantic.
We will not be able.
I think no project does at the moment, right? That's its own project, right? So I think if we do that smartly, and again, maybe via Ocean Data 2030, and tell the world what it really takes, it will help us get the appropriate funding to actually do this properly later. Because right now, I don't think the funders understand how hard it is to do this.
No, we definitely need to have. You know, first of all, it's not only you know, technical people here. It's a lot of domain expert that needs to be involved in order to do some kind of very, you know, in detail mapping and all of these different terms and elements. So yeah, Iliad is not going to be able to do something like at this level of detail. But the idea is first to provide like this kind of framework, as I mentioned. So Iliad is not only like the model itself, but it's like more the framework where you could then also integrate all of these other elements, right? So that you could then make it additional mapping representations or whatever into this kind of framework. That's one of the main interest of the Iliad itself, I would say.
But yeah, so Pierluigi, back to the hackathon here. Did I hear a potential team in the hackathon working specifically on this topic and with the goal to position this team to get funding for implementing some plans?
No, I think that sounds great. So because we already have a model, we actually published from ESIP, the Earth Science Information Partners, based on the cryosphere stuff that I just put in the chat. We published a kind of experience note saying, look, this is what it takes to do semantic mapping, right? The kinds of people you need to bring together, the process, etc. If we have a small team, focus, let's say on the EOVs, let's just get that sorted out, right?
Yes.
Like something small and defined. And then we can push that not just from a European project, but we do that in Ocean Data 2030 as a contribution, invite more global people to participate. And then, like, again, we'll have a technical basis to talk about this. So when people make these claims, they can back it up. Like, okay, if you said you're mapped, where is it? Is it in the same mapping file? Because if it's not, we can't do anything about it, right? So I think that's bringing down these conversations from like high-level aspirations to here's the file, and then you can give that to a coder. And that helps so much with language. Again, we have so many participants who are not in Turtle because the language is English mostly, right?
Yes,
and
yes.
If you just give people files like that a developer can use, they can work in their own language. So I think that's one of our greatest equity building mechanisms.
Yeah, absolutely. And fantastic. I see, Pierluigi, we will invite you to another more educational and topical webinar directly on interoperability in the hackathon. And then we can pursue this later. But now I see David Kettle. We have somebody else. So thank you, David. Do you want to take the floor?
Yeah, sure. I'm just going to start, I guess, by saying that for me, digital twin, this space is not something that I've been operating in for a long time. It's the first time I've sort of connected to some of these groups and people. We have a fairly new to the market visual survey tool capable of collecting huge amounts of visual imagery, 400,000 images a day. We pair that with a variety of water sensors, water quality sensors, as well as temperature and a range of other things. And then we run AI analysis of the imagery. So we're looking at fish identifications, urchins, sharks, turtles, as well as benthic habitat mapping, and pouring this all back into a 3D model at large scale, as in 100-kilometer transects is kind of where we start, and 100-meter transects is where we start, but 100-kilometer, 1,000-kilometer, 5,000-kilometer transects is sort of where we're heading. We can do easily single machine 100 kilometers in a day. So yeah, looking at I've been playing recently with Cesium and Unreal Engine and bringing some of our 3D models into the sort of real world digital twin in Cesium, and then overlaying some of our data back in there, putting some of our fish identifications back in, and giving people the ability to visualize what that environment was like at the time when we collected the data.
So does this mean that this interoperability issue is something that you would like to work on to connect with even more data and even provide data to the community, perhaps? It sounds like you have a lot of interesting data that could be useful for other purposes as well. But how do you...
like I said, we haven't yet connected with a lot of other groups. We've done a number of specific projects, which is reliant on just our data. But yes, certainly interested to know how we might bring other data into a project, how we might push data out to other projects.
Right.
Yeah.
Yes.
So I think, this is exactly why we built Otis in IODE as like a foundational data sharing layer and a kind of radar. So other stakeholders just know you have images in a certain region, right? So that's operational now. And it's, as Raul showed, it's JSON LD, so your developers will know what to do with it, and schema.org so that it can be picked up by Google Dataset Search and others. So what if you have like image data or video data or anything of that kind, the steps, the practical steps, create a metadata catalog that lists like a manifest of all of the things that you actually have and want to share. connect that to something like Otis, and then Turtle and all of the other digital twin systems will be aware of it automatically. So if they search for image data in a region, if you have geospatial metadata, they'll find your stuff without even knowing your name. And that's the point, right? So that's how we do it. So that's operational now. I'll put
Right. I think because I joined late, I suspect I've missed some link sharing early on. I would love if you could reshare that link.
Yeah, sure. And again, it's easy to do, and it doesn't work just for Otis. It works for any data system, and it bridges then into the Digital Twins Ditto program. If you're selling that, if you're a company and selling that, that's fine too, because the metadata, right? You don't have to provide direct access to the data if it's not free and open yet. You can add something for a negotiation page. The private sector is more than welcome to be part of this, because it's often much more cost effective to the public to simply buy the data than send a cruise out there or something, right? So yeah,
Sure.
there are ways to do that, certainly.
Great, thank you.
Yeah, and this is, I mean, the Iliad, so the Iliad project is actually producing multiple twins across different thematic. It's not only different on different locations, but also different thematic twins. So for fisheries, renewable energy, harbor management, it covers many different activities on the ocean. And so it's not like just an ocean model. Is actually an ocean model coupled with a lot of other factors, depending on the thematic that you are
indeed. But
Sure.
again, this is where the details come in, because if you have an international partner implementing something according to Iliad specifications, we have to make sure that that is fully interoperable with global requirements, right? Otherwise, it just dead ends at a European project, and we can't have that.
Yeah, but Pierluigi, here is so it's fantastic. I think we have a pathway to connect with the turtle community. Use that as a common denominator here, but we also are planning on bringing the ocean information. We are already including the ocean information model in the standard development in OGC, which is another global. It's not only European, right? It's OGC is global, the Open Geospatial Consortium.
Yeah, I get it. I mean, it is, but at the same time, something weird is happening at OGC. I put it in the chat too. They are an excellent standards community for geospatial data. That's what they're for, the Open Geospatial Consortium. But with OGC API, they've just reinvented DCAT and schema.org, and also kind of badly, right? So it's one thing to say, yes, we're working with X organization and Y organization. That doesn't necessarily mean you're doing something sensible, right? So this is something that, I mean, again, this is not necessarily a direct criticism of Iliad. I don't know the details, right? But I'm just very wary about this, because we've seen this all the time. People get the right rubber stamps and the implementations get worse, right? So I'm really hopeful for this hackathon series that we actually ground what we're doing in, like, the thing is actually working, not just like putting the right names on something and hoping for the best.
Yeah, I think that the important thing in at least getting in partner with real standard organizations like OGC is that we are at least getting some ensure that this would be implemented or at least supported by different solutions. And this is something that we know. For example, I don't know, SensorThings API is one of the most commonly used APIs that is being exposed by different solution providers working with measurements and observation. And it's very, quite a straightforward representation of model. Of course, there is many working groups improving all of these models, but at the end, working directly with all of these standard organizations that is not, trying to cover our traces back, not in Europe, as you are saying, but also trying to go also into, more global direction, of course. And again, it's not that Iliad would have the resources to, connect to everything that is out there, because we don't have all of the human resources to do that in the project, but we are having, providing all of these framework and capabilities in order to enable this to continue, in the future after Iliad.
But Pierluigi, I think what I've been thinking, being a former member of the hardcore ocean community, I have recognized the need to connect better with the GOOS, IOC, that global ocean community, to because it's thematic. the thematic knowledge that that needs a little bit more, a better connection with the geospatial component here. So you're absolutely right. I mean, we are all right. We want to connect these communities to be able to, I mean, for the interoperability. And it's been a missing. I try to, and again, it's about resources. I try to connect with the Geo Blue Planet, as you know, one means on the Earth observation side, and also the IOC, the GOOS, the IOD, you know, these different bodies working on ocean-related data and other parts, understanding of the ocean. It's sort of on what we try to achieve. So I'm very excited, Pierluigi, that you are giving us this our opportunity to work more concretely on making the connections. It sounds like we are on the right path.
It does, but it's also, you know, as you can probably tell, my job is to have the hard conversations, right? Beyond the sort of everything is great, and say, all right, let's figure out what we're actually doing. Because again, the data space is a gold rush, and it's gotten people far too excited, and they're moving into sort of territories that they don't understand how to actually work in. And again, if OGC starts to create redundant fields with schema, the response, oh, we'll just map it, is okay until it's not, because they've realized they've implemented the value spaces differently and it's not interoperable. So that's where we're going to be really careful. But again, from what you've shown in Iliad, you have all the pieces to actually do that interconversion smartly. But this is where like Ocean Data 2030, that program is going to be so important, because we're going to bring the tech people together from all of the actions and all of the projects, right? So we can actually have a very specific conversation on what we need to do and what systems are working now, right? For the we don't have that long left in the decade, right? So it's not a theoretical thing. If I hear like another model, I mean, your model builds on other models, so that's, you know, relatively good. But there are people who say, look, we have another, you know, one to rule them all. So that's the N+1 standards environment. And it doesn't matter if you're working with a standards agency, if it's already done and operational, what's going on? So I think that's why I'm so happy about Hackathon starting, because that's where we can actually have the time, not just to sort of back and forth in a conversation, but say, look, we can do this. It's working now. It's reaching millions of machines already. What are we doing, right? Why would we do something else?
You have talked your way deep into the hackathon now, Pierluigi. You are aware of that, right?
Yeah, sort of.
And on the other hand, but also, you know, I mean, I think that also we need to make sure that we are trying to follow what is really going to be, you know, like standard. I mean, I'm not, of course, fully aware of all the standards that are out there, you know, for the ocean domain, especially because I am not like a, you know, domain specialist, of course, but I need to make sure that, you know, whatever we are trying to build on is aligning what is becoming or is already like some kind of standard, and that if there is something else, of course, coming up later on, that we have this possibility to connect later on to these other upcoming things. So that's one thing, and the same with, you know, how to, you know, represent things or how to represent mappings, that kind of things. Again, trying to follow on what are really standards at the moment. You know, in our cases, for example, I'm interested in providing this kind of, you know, validation things that are based on standards. So I'm trying to do all of this kind of representation of the terms in a way that is a standard that can be used already by developers and that kind of thing. So I'm trying to follow what is there now as a standard, right? Of course, there can be more things. There can be potentially better ideas that are still not standards, but
that's exactly our logic too. Oh, Tom, you're intervening.
I'm gonna intervene and just as Piotr puts his hand up, because we're out of time today, but I think the fact that we've gone right up to the end of the hour, and we're still in deep discussions, shows that this is such an important topic for this hackathon. And so I just wanted to wrap up and say thank you to Pierluigi and to Raul for giving not only a presentation, but also a really active discussion and debate here. This is the first sort of time that we sort of talk about interoperability within the framework of this hackathon. I'm really excited and looking forward to what happens next and actually getting some work done. So with that, I'll just finish and say thank you everybody for joining. We've put links to the Hackathon webpage in the chat. I think Bente will probably do it again so that you can sign up, you can pre-register for the Hackathon to follow along online, get more involved in these discussions, and actually start working on actually solving some of these challenges that we've already touched on today. This concludes the 3 kickoff webinars for the hackathon, where we present the themes and do a little bit of introduction to the themes. So when we come back, it will be a lot more of a working session. So be prepared for that next time that you join. It won't be so many presentations. It will be more getting to work. And yeah, so we look forward to that. So thank you everybody for joining. And thank you to our speakers, and thank you to Bente for organising this. I hope you will have a good day.